Ladies and gentlemen, in today's video, which is the second part of making the Snowflake tower, I will continue from where we stopped last time. And as you remember, we was making a custom node for the Snowflake tower. That's part of making a parametric plan outline, and we was just creating the points based on its cylindrical coordinates. And we said that we need a P1, P2, and then E1, E2, and E3. So don't forget that we have a yellow background, so we are again in a custom node, and I already have this the same exact plan ready and finished here. But if you can notice the white background, so it's a normal Dynamo base file. It's a DYN. And I will show you that I get the privilege to show you the both difference in both methods and what's the pros and cons in both of them. Especially when you go to the here the Dynamo function, which is the custom node, which is the yellow background, also have its extra bonus, and it have the downside also that I'm going to show you now. So let's continue this again. Gonna create 3 points for us. And we technically need to get those points individually, and we can use a get item or a list.getItem, or we can use an easier way, just double clicking here and try to use this method, which is technically getting the results as a separated points, all of them in the same time, instead of writing or actually creating 6 nodes, 3 for get index and 3 for the numbers. This code block will allow us to get points, and here we get each points we need from those 3 points that we generated here. Sadly, in this method, when you click on the node itself, you cannot see the points highlighted, which is this is a really downside. But if you look at this method, which is the normal Dynamo file, the DYN format, if you click in here, you're going to see those highlighted. That will make your life way much easier. So again, guys, if you are designing this for the first time, and again you are designing it not like me now, just following whatever I'm going to do, it would really good idea to start it here, and then you can just switch it and save that or create a custom node out of it by coming to here and create node out of the selection. And then you have to go there again to the DYN and finish the parts that you cannot do in here. But the point is, working here is easier, and it's good for you if you're still designing. But if you finalize that and you want to clean things up, you can just go ahead and do as I do here and create it in the in the dynamic or Dynamo function actually, or Dynamo custom node as I'm having here. Anyway, so quickly you need to repeat that several times for each set of those. Except this have 6 points generated, so you have to continue. So now we have 6 outputs for each points of those guys in here. As you can see in the Dynamo file base, I just group those, as you can see, but I think grouping function is not available in here. I don't know if it's available or not, so can I hit Control and G? Oh good, so it's available here too. So it would be a good idea to group them. Just ungroup for now. That's you can easily categorize the whole thing. Just select this, Control G, and just give it the name like a point maker. I think the issue that drives me to go against this is that when you just create those groups and then you send that to a custom node, it's gonna make a mess when you open it here in the Dynamo function for Dynamo custom nodes. So that's why I'm a way of making it groups and then send it here. Should be making it as a group and then probably copying it rather than what I'm doing right now. That makes no sense. Anyway, so now we have those points. We need to create a list, and from that list we need to create a polygon. So generally we need a polygon by points, which is this guy. That's what we need. But the problem, if you look at the input of that guy, it's inputs, so it's a plural, so whenever you can get any of those points, it will not work. See? So you need a list to create or to combine all this. So just list.create. Now that's the thing here. You need to have a look at those points and where they are. So I'm going to start up from this point, which is that 0, 0. So you're going to find it in E actually. So you're going to find this at the exactly at E3. So it should be at 0, 0. So this one, which is the first point, so you're going to connect this point actually in here. Now we need the one that was located at 30, which will be, it's actually this point. That's what we need now, because we're technically going to ignore anything that's related to the E1 and E2, because you know that we need to go with a polygon now, running through those major points. That's the one in here, the central imaginary point, and then run toward E3, then toward it's from P1 to E3 to P2 and so on. So we're avoiding E2 because it's not being created. You should create a circle first and then use that. So it's useless now to depend on E2, and it's also useless to depend on E1 also. So I'm going to avoid using those two for the time being. We're going to use them again when we create the curves. So when you get back, so it's a good idea to choose those two things, which is E1 and E2, and push them a little bit away so we don't get confused with them. So again, this is the 0. Now we need to jump toward P2. So P2 will be providing something with 30, so it's the first input, 30. It will be the second one here, and then we need 60 that E3 provided here, which is the second point. Now we need to go ahead and do the P1 90 degree. So that's the first point here, as you can see. Back to that again, E3, which is, I think it's 100 and something, 120. Again, it's a P3, so this one, the third point, or the third output. Now, after that, it's again P2. So you go to P2, it's 150, second point. And if you connect now, you're going to see that it's actually generating the shape for us. So the more you add income, or input, sorry, it's going to be disappear again, so it's okay for now. E380, that's the fourth, which is here, point number 3. And then again it's a P1, it's a 210 second outcome. And then we go to E3 again, too much E3s in here, and it should be 240, the one before the last. And when you connect it, you should have seen, that's almost completed. I'm gonna add a couple of points again. Now it's P2, something going down like minus 90 or 270, the last one here, and then again E3. So this is E3, the last one of it. So that's in here. Again, one last point, I think. It should be P1. And by that, it's the last one of it. And by that, we are generating the polygon that we are actually looking for. And that one, we need to find for it the intersection point with those circles. So we need 3 circles at P1 controlled by R1, and the same thing, big circles here controlled by R2. So we need to do that so we can find the intersection, and that can be easily done by writing a circle in here, and probably we needed 2 of them. We need a slider too. It's a numerical one, and this guy will be just renamed to be R1, and again this guy should be renamed to R2. Probably it shouldn't be like more than, I don't know, 20. Maybe we shouldn't change that anyway. So we're gonna connect, that to the radius and that to the radius. Again, R1 out of the something here like 2 by 9, so that's 2, that's 9. Then you can see it's been generated here. And for R1, if you remember, they are connected to the P1, so whatever the P1 provide us, this one, you send it to the center of the first radius, and you're gonna find them here. And the same thing with this guy, you're gonna send it to here. So easy and quick. Probably those to be controlled by something to call circle maker. And again, they are actually providing us, so when you stop in here, you see that you cannot see the location and the amount of circles. That's really annoying. That's a downside of using the custom node here in Dynamo. So again, let me compare it to this guy, for example. See the circle maker? When you stop in here and you see what you have, and that's really useful for us. So again, don't use the Dynamo custom node unless you are 100% finishing out of the design process. Back to Dynamo. So now we have the polygon represented by this guy, and we have the circle represented by those 2 things. So we need now to go to geometry intersection. So here we need 2 of them. That's 1, that's 2. That will define this geometry, which immediately gonna disappear. So here we go for the second downside, that sometimes you can find the geometry actually disappearing for no reason. And that's again just to see the geometry. So if you notice that it's actually created here, it's cut out the circles, which make no sense, by the way. And you see the intersection of those big circles with the polygon, and then the intersection of the small circle with this polygon. I'll just go ahead to the to the Dynamo file and show you what's happening in here. It's easier. So you see this? That's 1, 2, 1, 2, 1, 2 with the small one, and again 1, 2, 1, 2, 1, 2 with the big one. So that might be more, again, less pain to deal with when you in the earliest phases of the design. So now we need to flatten the point. Again, why we need to flatten the points, probably you might ask, again, because you're going to have them in a sublist or a nested list, then we don't want that. We want them just to be plain, so we can get used out of them by using this straightforward point rather than having them in a subcategory, which we don't want that. So we need to flatten them, and then we use this code block of a 6, so we get them as an outputs to use them easy. And I'm gonna steal that guy from here. Now we get to connect this here, and the same thing to copy that one. I'll group those with Control G. These should be coming from R1, right? Yep. So this is the intersection generated by R2. Now that's been said, we need now to create arc, and the best way is just arc by 3 points, and I think that the picture already saying that these are just arc drawn by 3 points. I'm going to start drawing this one starting from this point here, running through E3 and then ending with the intersection. So from the intersection of R1 to the intersection of R2. Now the painful thing is you really need to understand it's really painful process if you didn't do that before in the Dynamo environment, because I can know that this point, for example, let's say that I want to draw the first arc, which is this guy in here. See this guy, let me just zoom in, just this guy. When you select the arc, you're gonna see it, and each point was actually part of that, like this point. When you select it, you know that you're gonna start from this point, and you're gonna end up with R2, and that's the first point. So you're gonna select this guy, you're gonna know you're starting from this point to this point, but you cannot do that all the times in here, because you actually cannot access those points, and that's really annoying. So again, you can use this when you actually knows exactly from where you're gonna start to where you're gonna end, and otherwise it's gonna be really painful, because there's lots of point to try and to do try and error with it. So that's my first point again, and an R2. This is my last point, and the midpoint should be something in E3, and it should be 0. So it should be the first one again. See, so now this arc is actually drawn, and something again it's look like wrong. No, it's actually okay. So starting from this and literally ending at this point. So do we really need to create another circle? I don't know. Yep, that's the circles. They make no sense, but it will help us to see if we are working okay. It's working okay. I'm going to delete them after we finish. So that's the first arc. I'm going to copy it down. And a good thing to ease the pain is you're going to remove the first one, the second one, and the last point, which is this point, it will be in here, will be the first point in here. Just move that to here. That can be really reduced the amount of work we need to do. So we're going to go to E2 this time. We didn't use that before, and we're going to use the first one in E2. That's the mid, and then we're going to go to R2, the first point. So that's R2, that's our first point. See? So we got this arc, which is exactly this one. Now we copy this one. Following the same rule, get rid of the first, get rid of the second, and the third, make it the first point. So now we need E3 first point. That's my first point, or point number 1 actually. It isn't the first actually. And then we need to have R1, that's R1, and then 0. So see, started from here, running in E and ending up by this one. Those are the first 3 points. Now we have this guy here. Again, removing this, removing that, and making the third as the first. So this is our 4th point, and now we need E1, the number 0. That's E1, and that's the 0. It will be the middle one. And then we need R1, point number 1. So R1, point number 1. And I'm wondering where it is. Should be somewhere here, I guess. Yep. So if I remove this guy, yeah, here, see, here it goes. So I'm gonna undo. Right. We didn't see it because it's exactly under that circle. So point number 5, same technique. Point number 5, we need E through point number 2 or port number 2. That's E. Sorry, it's a port. It's E3. Yep. And it should be port number 2, which is this guy. And the final one is R2, point or port number 2. Good. So it's working. Now point number 6. You can see it's a bit of laggy because it's already drawing things in here. So if I go, you see, this guy is still existed and it's drawing things in here. That's why you see some kind of lagging when you work. Anyway, point number 6, so E2. This is E2, and we're going to have the first one. And then we're going to go R2, port 3. I'm going to have to copy that one, zooming out a little bit. So we have now 3 points, so this is number 7. So first 3, then the second 3, just to group them easier. Yep. So we have point number 7. So we're going to remove this guy, and we're going to make this is the first. So in number 7, we're going to have E3. You're going to go to E3. We're going to have port number 3. And then we're going to have to R1 and port number 2. As you can see, now number 8, remove, and then remove that guy in here. And in 8, we need E1. I'm gonna go to the first point, and then we're gonna go R1, the last, that's R1, and it's a P3 here, the third port. Yep, we didn't see it again because it's here, so okay, it's always freaking me out. We remove those things and you can see the lagging continues. So now the point number 9, E3, that's E3 in the fourth, and we need R2 again fourth. Now I think last 2 So we gotta get rid of this guy and this guy making the first. Now number 10, actually there's a 3 remaining, so we need E2 and port number 2 and R2 port number 5. See, that's in here. Now we need this guy and then this guy to close and finish everything. So point number 11, almost there. I know it's boring, and again I got this already written and prepared, and if you need to try them out, you have to go to the the Dynamo normal file, not in the custom node, in order to make it easier for yourself. That's point 5. This is the hardest part actually. That's R1, and then that's the 4th point, or the 4th port, sorry, the 4th port. That's it, almost. So the last point, which is going to be making this bit. Get rid of all those, remove this guy in here, and we need E1 second port, so that's E1, that's the last port in it. We have to put it in here, and then we're gonna use R1, the last port. That's the R1, and this is our last port in here. And of course you're not gonna see anything because it's under the circle. So now we need to get rid of the extra stuff, like this circle we did, remove it, and we need to remove that guy. And you can see now those are the curves we made. We need also to off the list in here, probably make it without this preview. We don't need this, actually, just to remove this extra guy that we made. Now you see this is the shape we was looking for. That's our parametric plan or parametric outline that we are killing ourselves here to make it, and it's ready for us. But the problem is this: if you go to the I'm just gonna save, if you go to Dynamo, the project we are just placing that in, now things getting more interesting, huh? See, that guy you placed have lots of outputs, and all of them are just separated lines, and we don't want that. We're supposed to have a continuous polyline in order to make extrude or loft in it or whatever. It doesn't work to have like a separated entities. We're not making surfaces all the time, so we're probably making a solid geometry out of that. So we need something called polycurve, okay, and you need to depend on joining by joint curves. So when you apply that, same sad issue, it's curves, and in this case again we're gonna need list. God, that's annoying. Alright, so but this time it won't be that much painful. That's the first. Just continue to follow the sequence to create them. I wish that Dynamo not crashing on us now, because I will be really sad. 1, 2, 3, 4. You can see the curves actually disappearing, and that's again make a complete no sense. That's to add to the downsides of using the Dynamo function or the custom nodes. It shouldn't be deleted. You're making a copy of it. 8. For some reason I made a mistake. No, I didn't. 1, 2, and 3. Let's do it. So that's 9. That's 10. And that's the last one. So we all of them made them now in a one list. So just easy get this to that, and that's it. So now we have one object to control all of them. That's what we want, and it's a complete healthy polyline, a closed geometry. So I'm gonna save. That's about it, guys. We created now successfully the polygon. And if we just have a look at the Dynamo here, you're gonna see that this is the geometry we was looking for, and it's a fully parametric. Now we need to, you know, like just as easy as it goes, we can just close that guy and deal this each time, or add this each time we want to add this, but add the polyline or the parametric plan, sorry. But the thing that it doesn't make any sense, that we need to see, we are seeing here just the polygon outlines. You just need, maybe you need to add extrude to it. It's okay if the dimensions are fixed, but we are not making this, or we're getting all this painful process for making a Dynamo custom node and a full function just to do this once. If we are doing this once, we shouldn't go and make it as a custom node, right? So, and the custom node now providing for us only an output, one output that allow us to have the results. There is no inputs, which is a technique that's a really bad thing to be done. So we need to get back to the custom node again, and we need to customize the way we actually getting our inputs. That's why we are in here from the beginning. And we can go here and add something called inputs. That's the input that you don't find in the normal Dynamo file. This guy. In it, I'll call this P1. And in it I will say P1 equal to 42. It's just a default value, okay? And I'm gonna connect this to the radius. Now I cancel that guy, okay? It's just being canceled now. So now if I save and I go to the project environment again, sorry, to the Dynamo file again, oops. Now I have inputs, right? So if I want to, that's where we're gonna work in here. We always work in here. So what we have to do is just to make a slider here, and you know, like create any number you like this, connected, and you can see that P1 is actually responding dynamically and creating crazy different proposals and shapes out of the node that we are just working right now. Probably we can call that P1, so we know that this is linked to this. It's already been stated here clearly, but anyway. So that's the way, that's the first thing, and you can see it's now kind of getting messy. That we have a different values popping out of that, but it's okay. We're gonna fix that later. Back to this, and I'm gonna copy that down and doing the same thing in here. That's a P2, and it's a default value of a 25. So it's a default value. It's not a fixed thing. That's why it's been provided. You can delete that if you want. And repeating this several times. This should go to E1. And the default value for it 40. That's an E2, and the default value is 18. If you don't add the default value, you might get error message or a crazy shape when you first time place this. It's really important to write the name, so you know what is it in the input, and you write the equal sign and give it a default value. Otherwise you're going to get an error message or a crazy result or a crashing thing there, and trust me, you don't want that. So again, this is not a fixed value, guys. That's why I keep repeating this. It's just the default value for it. And also don't forget those two things in here, the R1 and R2 are actually part of our work, so don't forget. So in R1, that's the radius. So guys, you might ask now why we did the slider from the beginning here. I did that so if you need to test the work now during the design process, you can do that easily. Anyway, I'm gonna save. I'm gonna go back to the project, and you can see now we have all the inputs, and for some crazy reason all of them named P1. Make no sense. So what did I do wrong? Okay, now that's why. That should be R. That should be R. P1. That's a P2. That should be E1. And that should be E2. And that should be E3. Is it? That's E3. Again, that's E2. And that's it, almost. So save. Go back here. Actually, it's a project. So now you see that's created still R's. Oh God. R1 and R2 should be fixed. That's R2. So now it's okay. Now we can go ahead. You see now the function is working perfectly. Even I didn't feed yet those, slider to it. So again, it's a P1, P2, and the P2 should goes like we say 25. E1 should goes to 40, and E2 should goes like 18, and E3 should go to have a 31. Connect the dots to here and here, and probably we need 2 R's, so R1 and it's 2 or something, and R2 it's 9 or something. Those should be connected to the correct places. Now you see that's what we want. Now you go ahead and flex. That's the scary part, and you can increase one of the axes, as you can see, and an overlap will generate. So you need to change the E2 with it. Actually, I should change the E1 with it. See, it's now more like triangular shape. You can go to change an E3 to get it more like puffed or pumped out, to make it more circular shape. So you can see, guys, it's amazing thing. Like, it's no need anymore to make several plan. You can make one parametric node, and that node can give you all the crazy shape in the universe. See, it's really an important thing to use to, is to deal with the concept of a parametric plan. Why you should accept to have one shape while you can make like all the possible shapes of that. Okay, have a look. We're just gonna cut the preview out of that. Now you see in here you have two shapes, multiple. It's a complex geometry that you actually can build, and there is no limits for the shapes that you can generate out of that. You can see here. And if you look at what the lava architects, when they designed this Snowflake beautiful tower, you can see that they actually created several shapes by giving different numbers, like it's more like longitudinal parts, closer to full triangle almost, getting more circular, like a circle shape, and then get back to triangle, exact, clear and obvious triangle. And that's really beautiful to get different shapes like this, that they look like a totally unique shape, but in truth there's a set of parameters, a fixed set of parameters that you can change their value, but they are actually exist and define different proposals for you. So again, that's how it can go. It's a beautiful aspect. You can just go ahead and test those values and get this result in your own time. I don't want to make it even longer longer time tutorial, longer than that. Probably we need to get back and get rid of all those. That's annoying because we don't need all those curves to be considered as an output. So probably we come here and use this output. And we say that it's a polycurve. You see that's getting us rid of all those things that actually Dynamo considers them as an output when place them by one thing in here. And you see there's no names for it because I just named the head here. It should be goes here to again polycurve if you want that to be shown back in the project like this again. So that's our polycurve, and it's made out of 12 sub curves, as you can see in here. I can just go ahead and delete those guys. Keeping only one, and I will leave you guys to experience the possibilities that you can get for the time being. It's really amazing. That's endless proposals of plans that can be generated. That's what you can call it as a parametric plan or parametric outline. Call it whatever you want to call it. You see now it's more like a ninja shape triangle. That's really crazy, like a really nice, and it's a limitless proposal of shapes you can get in here. Anyway, that's it for today's video, for the second part, and then I wish in the very soon I can get to upload for you how we continue from now that we have now a nice a custom node. And if you go to the category, the new category that I call it Firas 3, you have your custom node now. When you ever drop it, you're gonna get a new shape like this. Imagine you can extrude that and you make that as a void. Anyway, so you can use that as a custom node in all the files you want and create different plans from it. And in the next tutorial, the step 3, we're going to go is more like to talk about how you can accumulate them vertically to create a parametric tower now, and control the height of the floors to generate the overall mass or the overall form of the building, whether to create, as we said in the first part, the external skin or the cladding of it, or to create the main body of the building, that from it we can drive the slabs. Anyway, please don't forget to help this channel by subscribing and share and like this video. Thank you very much, and have a good day. Bye bye.